from our last video, just to compare, if we graphed it in Desmos, as you can see, they're exactly the same. Well, they look the same, right? But let's double check. So our vertex is going to be 1, -4, which does match what we said over here. My y-intercept we said was 0, -3. And in this case, it 100% is. So we did graph it right so far. And if we have one of our x-intercepts is at -1, 0, which is correct, and 3, 0. So we definitely graphed it correctly. So let's try our last problem here, function e, and we're going to do the exact same thing. So what we're going to do is create an x and y table, choose some points. I'm actually going to choose some negative numbers now. So I'm going to do like -2, -1, 0, 1, and 2. I want to get a mix of both types. That way I know, hey, where's my y-intercept, where's my vertex, and so on and so forth. So what we're going to do is similar to what we did last time. Anywhere I see an x, whatever my input is what I'm going to put there. So for my first one here, I have y equals, parentheses, -2 squared, plus 6 times a -2 minus 5, because I'm starting with my first number is -2. Well, a negative times a negative is a positive. 2 times 2 is 4. Oops, now I have 6 times a -2. Well, they're both opposite signs, so a positive times a negative is a negative. 6 times 2 is 12. I'm going to bring down my -5. So 4 minus 12 is going to give me a negative number. It's going to give me -8. And then I bring down my -5. -8 and a -5 are going to give me a -13. So I know my first point on my x-axis is, on my table is -13. Then I'm going to do 1. Y equals -1 squared. Let me move this over a little bit so you can see. Plus 6 times a -1 minus 5. Well, -1 times -1 is a positive 1. A negative times a positive is a negative. And if I bring everything down, 6 times 1 is -1. Or sorry, -6. 1 minus 6 is -5. Minus a 5. Remember the keep, change, so keep the first number the same, change the sign to positive, and change the second number to a negative. So -5 plus -5 is -10. And then I'm going to do 0 now, which might be a little bit easier to do. Anything times 0 is 0. So 0 to the power of 2 is 0. 6 times 0 is 0. And I bring down my -5, and this answer is actually going to give me -5. And if I keep going, now I'm in the positive numbers. So a positive 1 squared plus 6 times 1 minus 5. So 1 squared is 1. 6 times 1 is 6 minus 5. I'm going to add 6 plus 1 first, which is 7. And 7 minus 5 is going to give me a 2. Then for my last one here, I have 2. So I have y equals 2 squared plus 6 times 2 minus 5. And honestly, you can choose any numbers. You could choose 1. You could choose all positive numbers. You could choose all negative numbers. I just decided for this one, I'm actually going to use positive and negative numbers so I can see where on both sides of my parabola where they're going to be. So now I have everything done. I can't go all the way up to all the way down to -13 because my graph is only to 10. But what I can graph is -1, -10, which is going to be right here. So where that green dot is going to be where our 1, -10 is. And our 0, 5, or sorry, negative 5. 1, 2, 3, 4, 5 is going to be right there. And then I have a 1, 1, 2. And then my other one is going to be 2, 11. So I'll graph that in orange, which is going to be off the graph up here. So we can't really tell what our x and y intercepts are or where my vertex is. So what's really going to help us is maybe we choose a little bit larger number, such as maybe a 4. So let's do 4 real quick. So I have y equals 4 squared plus 6 times 4 minus 5, 16, and 24. So that's going to give me a super large number. So in this kind of situation where we really can't see what everything will be, what we're actually going to do is graph this on a calculator and see, hey, where is these, where is this parabola going to hit its maximum? Because as I can see here, I have more points going up than anything else. So I know that it's going to be concave down, meaning it's going to have a maximum. But I definitely can't answer one of these questions what my y-intercept is, which is actually going to be 0, negative 5. So let's graph this on your graphing calculator here. We have x squared plus 6x minus a 5. Oops. So as you can see, actually, I was a little bit wrong. What actually happened here is, have a y-intercept of 0, negative 5. But in this case, I predicted that it was going to actually concave down and we were going to have a maximum. In this case, when we actually do graph it, we actually have a minimum and it's concave up. So it's okay to be wrong sometimes. It happens, and honestly, we could have chosen a different number on the negative side to see where that would be, like if there was going to be any negative numbers. So what actually we're going to do is we're going to record our y-intercepts. So it looks like our x-intercepts. It looks like it's going to be at 0.742. So my first x is going to be 0.742 and my y is going to be 0. And my second x-intercept is going to be at negative 6.742. So negative 6.742 and 0, which makes absolute sense because if you look, oops, that's the wrong one. If you look at our x-intercepts, they should be about the same, or they should be 100% the same distance away from our axis of symmetry. So in this case, our axis of symmetry and our vertex is going to be, our axis of symmetry, is negative 3, and our vertex is negative 3, negative 14. Oops. And if I chose another point, let's do something fun that we've already solved here, negative 2, negative 13. So graphing and using the Desmos calculator can help us see what the parabola will look like and help us determine what the vertex, the y-intercept, and the x-intercepts or intercept is going to be. So now that you have completed our lesson today, what you're going to do is go on and finish your 4th checkpoint. It's called Equations to Graphs. So when you open it, it should look something like this. So it's essentially the same thing that we just did here. And what's going to happen is you are going to be using Desmos, and I want you to graph it. What you do is take a screenshot of it and start graphing it. I want you to tell us what the vertex, the concavity, meaning is it going to concave up or down, and what the axis of symmetry is. So such as x equals negative 2, or in our case here, our line of symmetry was at -3. So go ahead and get started on that.